この会場はですね、ルーム A にある、ダニエル・アイゼンバーグさんの、クラスフィールドに関する、発表です。で、ダニエル・アイゼンバーグさんは、TC39 の、メンバーの一人ですね。で、今はイガリアという会社にいて、イガリアという会社で、ブラウザの、ブラウザですね、JavaScript の仕様を決めながら働いているという方です。So, yes, okay. So let's your talk.
Hello, as Yusuke probably said, I'm Daniel Ehrenberg. I came here to talk to you about some new features that are coming to JavaScript classes, specifically private fields and private methods, but we'll talk about some other features as well. I work for a company called Igalia, which is a software consultancy in Spain working on browsers and JavaScript and other things. And I'm a delegate in TC39, the JavaScript Standards Committee, which I'll explain in a bit what we do in TC39. So first, let's look at an example of a use of ES6 classes. This is a custom element. So this is a counter class, which is a type of HTML element. And when you click on it, it increments a counter. So see how it works. You can put it in CodePen. The HTML is just a num counter tag. And then the JavaScript makes it increment when you click on it. So click, it goes up to 2. So how does this work? First, the clicked method, each one of these things, clicked, connected callback, render callback, are methods. The clicked method, when it's called, it increments the counter, and it queues a task to re-render. The constructor, so when we create the element, it calls the super constructor, so it sets it up as an HTML element, and it registers a click handler, which calls this underscore clicked method that was defined above. And it initializes the counter to 0. The connected callback, when this is attached to the document, it renders, and the render function just sets the text content. It sets the text that the element contains to the counter converted to a string. So finally, we define it as a custom element with the name num-counter. So this can be improved using new features that are coming out for JavaScript classes. First, rather than defining this underscore x property inline as a property in the constructor, we can define it ahead of time as a field in the class body itself. So we do underscore x equals 0. And second, for things that are only used inside of the class, like this x and like this clicked method, we can make them private by using a hash instead of an underscore. So hash is the new underscore when you want strong encapsulation. For example, underscore doesn't actually provide privacy. With underscore, you can still see everything outside of the class. So in this public class counter, we have this field underscore x, but it turns out we can just log what that underscore x value is directly. A lot of times it's useful to do this. A lot of times it's useful to have your property actually be public, but just discourage people from using it with an underscore. This could be nice for debugging. But sometimes you actually want to keep something hidden. And that's what hash does. If we use a hash instead of an underscore, then you get a syntax error when trying to access it outside of the class. But is this JavaScript? It doesn't look like the JavaScript that I know. Well, it's coming soon. Private fields and methods are at stage 3 in TC39's process. So what is TC39? Well, remember ES6 or ES 2015? That brought you features like destructuring assignment, where you could do something like define x and y as 1 and 2, and then swap them using this convenient array syntax. Just like you can in Python, you just put x comma y on the left-hand side, and it unpacks the array to the other array and swaps them. But who is TC39? It's a group of people, it's a committee of this organization, ECMA International. Geneva-based standards organization, kind of like the W3C. And it includes members such as JavaScript developers, implementers, people who make JavaScript actually work in web browsers and Node by writing the things like V8, frameworks. We have React and Angular have for a long time been represented in the committee. We also have academics, people who study programming languages in the abstract, and we all get together to work on this, the JavaScript specification. So I wouldn't recommend printing this out or even trying to read it from the start to the end, because it's 1,200 pages long, but it's this very big HTML document that you could find the exact definition of what JavaScript is, of what happens when you try to run a JavaScript program. And we developed this document here on GitHub. This JavaScript specification is an open source project like many others, where we have issues and pull requests, and we talk about the changes that we want to make, and anyone can come in and propose a change online. But in addition to GitHub, we also have meetings. Every 2 months we meet for 3 days to discuss both things that are going on in GitHub, as well as bigger proposals that happen outside of the main repository. So let's talk about how classes came into JavaScript through TC39. Classes have been under discussion for a very long time. In the development of ES2 way back in 1998, so just a couple of years, 1 year after TC39 was first convened, once they got ES1 out of the door, people really wanted to get started on adding classes to JavaScript, because JavaScript only had functions. And you can still find some of these ES2 proposals using the Wayback Machine, and it's kind of hard to see here. It's kind of small, but there was this idea that you could have syntax, class foo extends var, you declare instance variables with var, and you have function declarations for methods. And over the last 20 years, there have been, 17 years until they got ES 2015 out with classes, there were several different class proposals. So in ES2 there was this one. In ES3 there was a long investigation into components. In ES4 there was a very advanced class system, which was sort of an evolution of what you saw before, including static types. When ES4 failed and was abandoned, ES5 was intentionally minimal. So it intentionally added very few things. And so it excluded classes. And then ES6 added maximally minimal classes. So what are these maximally minimal classes? Well, here's a simple example. We have a vector class, and it has a constructor. So this constructor part is what happens when you do new vector with x and y. Then it sets the properties x and y on it. And then it has a magnitude method where it calculates the, something based on the those properties. And ES6 classes are minimal in the sense that they're really based on the same object model as JavaScript had before. So JavaScript for a long time has had this way that you can define a function and then define properties of its prototype. So the function, when you use it with new, creates a new instance of vector. And then when you do an instance.magnitude, that ends up looking up the prototype chain and finding this magnitude method. So ES6 classes support, they have a bunch of different parts to how they work. In addition to basic methods, you can also have getters and setters. So like the onClick thing in the platform when you set enclave of an HTML element. That's calling a setter. You can define those using classes also. There's also static methods, so things that are defined on the constructor. There's support for subclassing, including proper handling of calls on the superclass. But they're missing a lot of other features that are present in class systems in other languages. And the lack of features makes it hard to adopt ES6 classes. For example, you don't declare your instance variables. There's no way to have privacy, and they're not programmable. So in other class systems, there's decorators. This minimalism was deliberate. The idea was to start small and then grow over time as it becomes clear what is really needed. So it makes sense that now we're coming back and looking at how to add private. Private has also been discussed for a long time. You can see it there in the ES2 draft. And so that was based on a private keyword, maybe something like what you have in TypeScript. But it turns out that it wouldn't really work in JavaScript to use private. And I'll have a slide that describes that in more detail later. There was also an idea to have private symbols. Symbols are a feature of ES6. You can see examples like symbol iterator, where it's not a string, but it can still be used as a property key. So you can have methods that are named by symbols. And there was an idea to use private symbols that you weren't able to access by reflection. Instead, in order to create privacy. But this was also found to be unworkable. Because of some interactions with the proxy feature, it would be really hard to make these genuinely private. And so around 2014, the committee shifted its focus to looking into private field declarations using a hash-based syntax, and especially with semantics based on weak maps. So the development of this happened under TC39's new stage process. For ES6, we didn't have the stage process, but what we set up post ES6 was that features go through these various stages in their development. At stage 1, we agree that we want to discuss an idea. And we discuss it in committee, it's sort of on the agenda. In stage 2, we get to a first draft. We have the proposal written out. There's an idea of what the semantics are, but it's still, but we still haven't nailed down all the details. But the important thing is, at stage 2, the committee has agreed that we want to go forward with this new language idea. At stage 3, more details are worked out. Really, the committee's decided we've thought this all through, we've designed the feature, and it's as ready to go as we can by just designing it. And then at stage 4, we have multiple implementations, and we're ready to say, this is part of the standard. So let's go through how this happened with private. So stage 1, when the feature is under discussion. The initial champion of the proposal was Kevin Smith. And Kevin actually wrote most of, or the vast majority of the current proposal. He did a really great job, very happy about his work. And so stage 1 is all about examining examining the problem space. So we looked at many different variants. We looked at this : field, this .hash field, fields. And you can see one of this, the : idea, elaborated in some earlier documents that the committee considered. Here, private fields were actually first-class objects. You would create a private map, and you would put it after 2 colons in order to access things in the private map. But eventually, we decided to go with this hash syntax. So these basic things were worked out while the proposal was at stage 1. So I want to describe a little bit more what I mean about the weak map semantics. So in particular, here's that vector example that we had before. You can declare hash x and hash y as the private fields that the vector object has, and in the constructor you can set them, but this won't work if you don't declare them. The declarations are mandatory, and then use them in methods. And what this translates to is basically that underscore x and underscore y are weak maps. They're a map that has the object as the key and the value of the field as the value. So if I create a new vector, then I will put in the underscore x weak map a mapping from that vector to its x coordinate, and the underscore y, the mapping from that vector to the y coordinate. And so they can be accessed by get. So with the semantics being driven by this weak map meaning, there's no way to get at the value of these private fields unless you're in the class, because the only way to access the weak map is through this hash syntax, which is only valid inside of the class. There's some interesting implications. Hash doesn't go up prototype chains. It just has to be accessed on that one instance. It's not frozen by object.freeze. So if you object.freeze a vector, the things inside will still be mutable because freeze won't affect the weak map. And hash doesn't tunnel to proxy targets. If you make a proxy of this vector, you're not able to access, if you call the magnitude method on that proxy, then it will fail because the proxy itself doesn't have, it's not present in the weak map. So it won't have the hash x or hash y fields. So everyone asks, why use the hash syntax? Why not use the private keyword? Because many people are pretty happy with the private syntax in TypeScript. But fundamentally, this won't work in the JavaScript that we have today. So JavaScript lacks static types. Even with private, we're still all dynamically typed. No types are known until runtime. So when you have a program, when you have a variable, that variable can take any value at all. So here's an example of this vector. Rather than having a magnitude method, let's make an equal method. So the equal method compares whether this is equal to the argument. So you can pass in a vector, and what it will do is check if the x value equals the other x value, and the y value equals the other y value. Well, that sounds great. So because it's dynamically typed, we can also pass in a different object as the argument. So here, let w equal an object that has those properties. When calling equal, other.x and other.y will either refer to the private field or it will refer to the property of the object. But we don't know until runtime. So if private fields and methods are based on weak map semantics, then we won't know until we have the particular object, whether to do a property load or whether to do the read of the weak map. And it just gets really complicated from there. We just have to know up front which one we're looking at. And using the hash symbol on both the definition and the usage makes it clear that we're asking for the weak map, not for the property access. Remember that property accesses can be complicated. They can look up the prototype chain, they can call a getter, and we can't just do extra property accesses. That would change the meaning of the program. So once we got through those basic issues, we were able to get to stage 2 in the standards process. So to get to stage 2, we needed a first draft of the specification text and agreement that we want to go ahead with the proposal. So in this stage, we solidified some details. We decided we're not going to have a keyword. There was an idea, in addition to the hash, you would also put some other keyword before the declaration, and we decided, no, that's not necessary. We decided in a very strong way that private is not accessible to metaprogramming. So some people thought that private should actually be kind of like using underscore variables, but maybe a little bit harder to accidentally use. And we decided, no, private is only accessible inside of the class, and if you expose it explicitly. And we also decided some details about the evaluation order, including how initializers work. So when you have a class with field declarations, you're allowed to give an initial value of those field declarations in the class. So you're allowed to do hash array, hash r equals an empty array. And what this does is each time you create a new instance, it creates a new empty array. This is really important because otherwise, if they all shared the same array, you would probably have bugs. I think Python works this way in some cases, and it's a frequent complaint. So this is evaluated when we run the constructor. There's also this in scope. So scope refers to the variables that you can access within an expression, and the scope of the thing that's on the right-hand side of the equal sign was a subject of intense debate. And we decided it should have this, and that even means that you can access other private fields that were defined earlier. But if you try to access a field that's defined later, it doesn't work. If you use an arrow function, this is bound with respect to that arrow function, and you can even do super method calls and call a new target. I'm going to skip the rest of this slide due to time limitations. So in stage 3, once we had this, we were able to advance to stage 3, meaning that we had complete spec text. We had a sign-off from the reviewers. The committee appoints 2 people to review the specification. And we decided it's ready to implement in web browsers. But once getting to stage 3, we still had some further intense debate. There was a debate about static private. So in particular, if you have a class that has a static field on the class, static means that the field or method is a property of the constructor rather than a property of the instance. So we could make this static method base.get, which will get that private field. But if you make a subclass, then this static method sub.get will try to get this .hash field on sub. But sub doesn't have the field because thinking about it as a weak map, the weak map will have base as a key, but it will not have a key for sub. So it throws a type error. There was some discussion about whether this was too bad behavior. And after almost more than 6 months of discussion, we decided actually this is fine. Another debate we had was whether semicolons should be required or optional after field declarations. And we ended up deciding they should be optional. But going forward with stage 3, I'd really like to try to complete as much outreach and design work as possible before stage 3. I'd really like to resolve as many issues as possible before. And then during stage 3, we can really pass this off to be implemented in native JavaScript engines. With things like Babel, they can be implemented at earlier stages, and those are good places to investigate experimenting. And then during stage 3, we can resolve concerns that come just from implementations rather than design concerns. So to get to stage 4, we will need 2 implementations, and this is in progress. We'll need conformance tests, so I'll describe in more detail, and we'll need a pull request against the main specification. Coming later, we'll have decorators for classes, where class declarations will be able to be simplified even more. So, to get involved, there's all kinds of things that we could use help in TC39. First, we discuss everything in GitHub issues. So each one of these proposals has its own GitHub repository, and I'd love to see feedback about whether proposals work for people, what pieces might be missing, if there's some semantics that should be handled differently. In private fields and methods, we had pretty contentious, actually, GitHub repository, but we examined many different alternatives. So, test262, I mentioned conformance tests being required for stage 4. Test262 is the conformance test repository for JavaScript. It includes tests that are shared between JavaScript implementations. And what we find is if something isn't tested, it's often not compatible between different engines. You'll have something that works in Chrome and doesn't work in Firefox because people working on Firefox just didn't know that there was the other behavior. It's a great way to find edge cases in specifications. Test262 is also an open source project on GitHub that you can go in and make pull requests. There are tons of open bugs there, and that's a great way to get started in helping out in TC39 if you're interested. So with private field tests, we have these completed upstream in Test262, but there's still work ongoing in private methods tests. Another big area is documentation and education. It's really important not just to have documentation written out to explain to JavaScript programmers how to use features. And also during the design process, it's very important to think about the mental models of JavaScript developers to understand how learnable things will be, and think about whether we should make this decision or that decision based on what will be the most amenable to education. So we do have a good amount of documentation for private methods, but it could be better. We have explainer documents, so whenever you write a specification, you start out by writing a big markdown file that explains the motivation and the high-level design and how you would use it. And there's documentation in MDN in progress, as well as a good introductory article. But we could use more documentation here. So if you're interested in getting involved, love to get in touch. And then implementation. The great thing is if you want to get involved in JavaScript, so much of the JavaScript infrastructure, from the implementations in browsers to different development tools, are open source projects. And many of them permit things to be checked in early, even before something is standard, behind a flag. So these projects are all happy to take pull requests from contributors, and they're very friendly. Private fields and methods are currently in progress in V8, JavaScript, and SpiderMonkey, as well as Babel and TypeScript. But it's something that if you want to get involved, you can work on. It's also possible to attend TC39 as a delegate. The typical way to do this is to join ECMA as a member, and so please contact me if you're interested in more details. So, to sum it up, to get involved in TC39, go to our website. Hash is the new underscore for when you want strong encapsulation. And I'm Daniel Ehrenberg. You can find me on Twitter or GitHub at Little Dan. So, thank you. Arigato.
はい。TC39 のプライベートフィールドクラスの話でした。すごく面白かったですね。どちらかというと、どうやって決まっているのかって分かっているからです。So, let's talk about the next time.